Hello, welcome to another maths tutorial at Gleaming Moon School, Umuahia. This is Mrs. Edith Igwe, and we'll be looking at writing numbers from decimal notation to standard form. In this video, SF06. So grab your maths book and pen, follow all the instructions that I will give you, practice the example exercises, and watch this video over and over and over, and in no time, you will become a master of mathematics. Okay, in this video, our objective will be to write numbers in ordinary form, which is also the decimal notation, as standard form. In our last video, SF05, we wrote numbers that are written in standard form as decimal notations. So in this video, we are doing the reverse of that, changing numbers that are in decimal notations to standard form. And you have, these are the prerequisites that you need to have mastered before this video. So if you haven't watched our previous videos in this unit, standard form, please, I would ask you to go back and watch them. At least these following prerequisites. So make sure you watch the video SF standard form. Make sure you watch the video SF01 powers of 10, SF02 whole numbers and decimals, SF03 multiply by powers of 10, and SF04 divide by powers of 10. These videos will help you to develop the foundational skills that you will need for this one, SF06 decimal notations to standard form. Okay. Now let's recap the format of standard form. What did we say is the format of standard form? How do we identify a number that is written in standard form? We said that a standard form number is written as A times 10 raised to the power of n. And A is a number greater or equal to 1 and less than 10. And I explained that this sign here, I explained that this sign, which is greater or equal to, means that it can be equal to 1, it can be more than 1. And also this sign here means that it is strictly less than 10. So that means 10 is not inclusive, okay? So that is what the number A would be. Any number that falls within this range can be your A in this format, okay? And then it is multiplied by a number 10, and this n here must be an integer, which we said that an integer is a whole number, okay? So an example would be 3.1 times 10 raised to the power of 5. And we know that 3.1 is a number that is between 1 and 10, okay? And we know that it has been multiplied, and we know that it's multiplied by a power of 10, and that power is an integer, okay? So this is what we mean by standard form. Any number that is within this format is a standard form. Okay. Now let's practice. We want to change from decimal notation to standard form. And the instruction here says, write these numbers in standard index form. Okay. So we have 52. How do we write 52? Now remember that when you have a whole number, that you have a decimal point at the end of that whole number. And because you have a decimal point at the end of that whole number, that means we need to make it a standard form. For us to make it a standard form, we need 52 to be a number between 1 and 10. And to do that, we are going to move our decimal point from here. We're going to move it from here backwards once. Okay, so we are dividing it by 10. Okay, so if we divide 52 by 10, we are going to get 5.2. Okay, so if we have 5.2, now remember we have moved our decimal point backwards because we have divided. Okay, So that means because our decimal point is moving backwards, we are going to have a positive integer. Okay, we are going to have a positive integer or a positive power. Okay, so with that, we have 5.2 times 10 raised to the power of 1. Okay, so we have divided it by 10 once. And because we have divided it by 10 once, our power is going to be 1. The power of 10 is going to be 1. And because also we have divided, the power would be a positive integer. Okay, so that gives us the answer 5.2 times 10 raised to the power of 1. So that would be your answer there. 5.2 times 10 raised to the power of 1. Now for number 2, we have 0.076. Now 0.076 is less than 1. Remember, the format of standard form is that A has to be between 1 and 10. But this number is less than 1, so we need to make it to be between 1 and 10. And for us to do that, we have a decimal point here already. We are going to move this decimal point to the right. So we go 1, 2. So that means we are moving our decimal point 2 times to the right. So that means we are multiplying. So the first time we move the decimal point, we multiply it by 10. And then the second time we move it again, we multiply it by 10 again. So on the whole, we have multiplied by 100. Or let's say we have multiplied it by 10 2 times. And you can see that our decimal point has moved to the right. And because it has moved to the right, we are going to have a negative integer as the power. So we are going to have a negative integer. Okay, so this would give us 7.6 times by 10. How many times did we times it by 10? 2 times. So we've moved it 2 times, we've multiplied by 10 2 times. So our power is going to be 2. And because we multiplied, we've gone to the right, we have a negative power. So it's going to be raised to the power of negative 2. And that gives you your answer there. 7.6 times 10 raised to the power of negative 2. Okay, so the things you need to bear in mind here, the 2 key things you need to bear in mind is when you're moving your decimal point to the left, you are dividing by 10. And when you're dividing by 10, your power is going to be a positive integer. And the number of times you divide by 10 or the number of times you move your decimal point will determine the number that your power of 10, the integer for the 10 would be. Okay, so in this case, we moved our decimal point once by dividing by 10 once, and we went to the left. And so our power of 10 is a positive 1. And in this case, we moved our decimal point 2 times to the right, which means we multiplied by 10 2 times. And because we've moved it to the right, our power is a negative integer. And that is why we have times 10 raised to the power of negative 2. Okay, I will advise you to pause the video now, copy this example, put in these annotations I've written. Make sure you understand my explanation. You can play it back again to listen to my explanation and make sure you understand the explanation. Okay, all right. Now I'm gonna ask you to answer these remaining questions. Answer question 3, 4, 5, and 6. So pause the video again and answer these questions. Apply the example that I've given you with the annotations that I have shown you here and answer these questions. Okay, so let's have a look at the answers. Get your pen, check your answers. If you got them right, give yourself a nice tick. If not, pay attention. I'm going to explain these answers. Okay, so for number 3, we have 625. Again, is a whole number, so that means we have a decimal point here. And because we have a decimal point here, we need to make it a number between 1 and 10. So we are going to move our decimal point 1, 2 times to the left. And because we've moved it 2 times to the left, it becomes 6.25 times 10 raised to the power of 2. Remember, when you move to the left, your power is a positive integer. Okay. For number 4, we have 3,147. Again, as a whole number, we have a decimal point here. And that decimal point, we need to move it 1, 2, 3 times to have it here. And now we've moved it 3 times. We have 3.147. And because we have moved it to the left, we also have a positive power. And then for number 5, our decimal point is here, is less than 1. We need to make the number between 1 and 10. So we move the decimal point 1, 2, 3, and 4. So the new decimal point is here. That makes it 6 times 10. And because we have moved it to the right, we have a negative power. And then finally for number 6, this is the whole number again. So that means our decimal point is here. So we are going to move the decimal point, sorry about that. Okay, so we are going to move the decimal point from here, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's where our new decimal point is, making it 3.4. And because we have moved it 9 times to the left, our power is a positive power. So when you move to the left, you have a positive power. But when you move to the right, you have a negative power. Okay, so negative power. Okay, so positive power means you're dividing by 10. Okay, you're dividing by 10. Negative power means you're multiplying by 10. Okay, so this is a very short one. I'm sure that all you need to do is to play this again, listen to my explanations, copy down the annotations, practice these questions over and over, and you will understand it. We have done all the foundational work in the previous videos. This is just to put all the skills together, okay? So now, what have you learned? I'm sure you have learned something from this short video. So I would ask you to follow the link to complete the quiz for this lesson, okay? You can find the link by clicking the arrow at the bottom of this video next to the title of this video. And don't forget to subscribe to our channels and click the bell icon so that you will be the first to know each time we upload a new video. Okay, visit our Facebook page, Gleaming Moon School, and you will find out a lot about our school and what we do. And also, you can visit our school office. If you live in Umuahia, we are located at Upstairs Line, World Bank Housing Estate. You can get in touch with us by phone or email. It's all up here on this screen. Our telephone number is at the top here, and our school email address is at the top here. You can send us an email, you can give us a call, you can send us a text message, or you can visit our school office, okay? And we are expecting to see you there. In our next lesson, we are going to have SF07, Laws of Indices. This is a higher level now. We have more or less finished with the junior secondary part. Laws of indices appears more in the senior secondary, okay? But if already you understand standard form, then I don't see the reason why you shouldn't go into laws of indices, even if you're in junior secondary or in upper primary, okay? So that's what we are going to do in our next lesson. We look at the laws that govern these index numbers where you have a power. Remember, index is the same as the power, or you can call it exponent. So as a noun, it's called indices. So we call it indices, laws of indices. We will be looking at laws of indices in our next lesson, SF07. Remember to subscribe to our channel, and I will see you there. Bye-bye.